Here are the answers to the study guide. First, some addition and subtraction of polynomial questions. Addition and subtraction of polynomials is also called combining like terms. To be like terms, the numbers have to be either constant numbers, that is no variable by them, or when there is a variable, the variables have to have the same exponent. For question 1, the number 8 is a constant term. There are no other constant terms to combine with the 8. The 8 remains in the answer. The 10n and the 3n are like terms. They both have an n. 10 n's and 3 n's is 13 n's. And so you write plus 13n next to the 8. Question 2, the negative 3 is a constant term. There's no other constant terms to combine with it. And so the answer still has in it negative 3. This x squared and this x squared are like terms. Recall that with no visible coefficient, it's automatically a 1. So 5 plus 1 is 6 x squareds. Number 3, there's a constant 10 added to the constant 12. That's 22. There is a 3p, later on a 2p. When you add those together, it makes 5p. Finally, there's a p to the third power. There are no other p to the third power terms to combine with it, and so there's a p to the third power in the answer. Question 4, 18x subtract 5x is 13x. Question 5, 4m squared subtract 4m squared is no m squareds. 3m subtract 12m is negative 9m. To do that, you subtract the coefficients. This negative 9 is obtained by going 3 subtract 12. Now the constants, negative 11 subtract negative 6 is negative 5. This negative 5 is obtained by going negative 11 subtract negative 6. This is equal to negative 11 plus 6, which is negative 5. Now some multiplication. Polynomials are multiplied using the distributive property. The distributive property is repeated multiplication, multiplying the monomial that's at the beginning by each term of the polynomial that's in parentheses. Number 6, 5 times x is 5x. 5 times 10 is positive 50. Number 7, 5a times 3a squared is 15a to the third power. 5a times 7a is 35a squared. And 5a times negative 1 is negative 5a. When a product involves a binomial times a binomial, the distributive property process is called FOIL. First, outer, inner, last. There's 4 multiplications involved because each of the terms in the first binomial have to be multiplied by each of the terms in the second binomial. X times x is x squared. X times 10 is 10x. Now shift your attention to the 5. 5 times x is 5x. 5 times 10 is 50. Often when you do FOIL, you'll create like terms from the outer and inner products, and those can be combined together. The final result is x squared plus 15x plus 50. Problem 9, 3x times 2x is 6x squared. 3x times negative 1 is negative 3x. 6 times 2x is plus 12x. And 6 times negative 1 is negative 6. Again, there's like terms in the middle. The final answer is 6x squared plus 9x minus 6. And number 10, 3x times 5x is 15x squared. 3x times negative 10 is negative 30x. Negative 2 times 5x is negative 10x. And negative 2 times negative 10 is positive 20. then combine like terms. Division of polynomials is done by dividing each term of the numerator by the denominator. You can think of this as distributing the division. 8x plus 12 divided by 2 is done by dividing the 8x by 2 and dividing the 12x by 2. This makes 4x plus 6. Number 12 is done in the same way. Divide each term of the numerator by the denominator. 12 divided by 3 is 4. N to the third power divided by n to the first power is n to the second power. Now put your attention on the 6n. 6 divided by 3 is 2. N divided by n cancels out, no n's. Now put your attention on the negative 24. Negative 24 divided by 3 is negative 8. We're also dividing by n, and that n that we're dividing is in the denominator. And so there's an n remaining in the denominator. Our next skill in Chapter 5 is called factoring. Factoring is when you rewrite a polynomial as a product of prime factors. In order to factor polynomials, you have to know the factors of numbers. For example, what are all the factors of 24? One pair of numbers is 1 and 24. Another pair is 2 and 12. Another pair is 3 and 8, and another pair is 4 and 6. That skill becomes important when you factor trinomials. Number 14, find the greatest common factor of 18 and 24. Find the greatest number that is a factor of 18 and of 24. Well, the factors of 18 are 1 and 18, 2 and 9, and 3 and 6. The factors of 24 are 1 and 24, 2 and 12, 3 and 8, and 4 and 6. Now, what's the greatest number that's common to both lists? That's 6. The GCF is 6. Now, ideally, you would be able to figure out that GCF mentally and not have to list all the numbers down like I did here. Number 15, find the GCF of these monomials. The largest divisor of 3 and 12 is the number 3. The letter x is also common to both terms. You need to use the least exponent on the x. In this case right here, it's just x to the first power, and so the greatest common factor can only contain x to the first power. Number 16, factor this binomial by factoring out the greatest common factor. So you investigate the 18 and the 12 and think about the GCF. That's 6. Then put a set of parentheses and complete the complementary factor. 6 times 3x squared is 18x squared, and 6 times positive 2 is 12. Number 17, factor out the GCF. The leading coefficient is negative, so the GCF will be negative. 4, 12, and 20 are all divisible by 4. There's also a variable in all terms, and in the last term, the a only goes to the first power, and so the GCF can only have a to the first power. Then put a set of parentheses and figure out the complementary factor. Negative 4a times a to the second power creates negative 4a to the third power. Negative 4a times negative 3a creates 12a squared. And negative 4a times negative 5 creates the 20a. In problem 16 and problem 17, the type of factoring that was done is called factoring out the GCF. But that's only one pattern of factoring. There are other patterns that we've studied. Number 18, factor the difference of squares. A difference of squares is a binomial that has a subtraction in the middle, hence the word difference. And the two things being subtracted are squares, hence the word squares in the name. A difference of squares is factored with two sets of parentheses. And the missing parts in the parentheses are obtained using your knowledge of square roots. The square root of n squared is n. You put an n here and an n here. The square root of 81 is 9. Put a 9 here and you put a 9 here. In order to create negative 81, one of the 9's must be positive and the other negative. Number 19 is also a difference of squares. So you use the double parenthesis pattern. The square root of 4x to the second power is 2x. The square root of 25 is 5. One of them needs a plus and the other needs a minus. Another special pattern to recognize is called a perfect square trinomial. And here's an example of one of those. First of all, it's a trinomial. It has 1, 2, 3 terms. It's called a perfect square trinomial because of the relationship between the first term, the last term, and the middle term. A perfect square trinomial factors as a binomial squared. And to get the missing parts, you use your understanding of square roots. The square root of x squared is x. The square root of 9 is 3. Because the middle term is positive, we need to use a positive sign. Number 21 is also a perfect square trinomial because the first term is a perfect square. The square root of m squared is m. The last term is a perfect square. The square root of 49 is 7. When you multiply those two results together, m times 7, that makes 7m. And then if you double that by timesing by 2, that makes 14m, and that is what's in the middle. So as soon as you recognize the pattern, then when you factor it, it's a binomial squared. M goes here, 7 goes here, and a minus sign in the middle. Now number 22, factor this trinomial. This one is not a perfect square trinomial. The first term is a perfect square, and the last term is also a perfect square. The square root of 4 is 2. However, when you take the square root of x squared and get x, and you take the square root of 4 and get 2, and multiply those together, it makes 2x. And then when you double it by timesing by 2, that makes 4x. And that is not what's in the middle. So this is not a perfect square trinomial. It's a regular trinomial. The factoring pattern is two sets of parentheses. X times x creates the x squared. 4 times 1 creates the 4. If we use a positive 4 and a positive 1 and figure out the outer product and the inner product, those add up to 5x. And that's the middle term. Number 23, this is a trinomial, so it factors with the double set of parentheses. X times x is the x squared. Negative 7 times negative 1 is positive 7. And negative 7 plus negative 1 is negative 8. Number 24, this is a trinomial, so it factors with the double set of parentheses. X times x makes x squared. Positive 5 times negative 3 makes negative 15. And 5 plus negative 3 adds up to positive 2. Number 25, this is a trinomial, so it factors using the double set of parentheses. X times x is the x squared. Negative 12 times positive 4 is negative 48. And negative 12 plus the positive 4 is negative 8. Now, when you're factoring trinomials, if you try all possible combinations of numbers and none of them ever work, you write the word prime. Number 26, this is a trinomial. It factors with two groups of parentheses. 2x times x is the 2x squared. There's a couple possibilities of numbers that multiply to make 6. One is 1 times 6, but another is 2 times 3. The center term is positive, so I want to have positive signs. But do I need to use 1 and 6 or 2 and 3? If I put a 1 here and a 6 here, then the outer product is 12x, and the inner product is 1x, and 12x plus 1x is 13x. And in the middle, it says 13x. Now, number 27, factor the 4-term polynomial using a technique called grouping. We're going to group the first 2 terms together and group the second 2 terms together and factor the GCF of each. So the greatest number that divides into 12 and 21 is 3. The letter x appears in both. So the letter x is part of the GCF. Now a set of parentheses. 3x times 4y is 12xy. 3x times positive 7 is 21x. Now move over to the second group. It starts with a negative sign, so we're going to have a negative as part of our GCF. The largest number that divides into 20 and 35 is 5. 5 times 4y makes the 20y, and 5 times a 7 makes the 35. Now I notice that we've created a common factor here and here. The final answer is going to have 2 groups of parentheses. The common factor is one of the factors. The other factor is created by putting the 3x with the minus 5. The last thing that we studied in Chapter 5 was solving quadratic equations and cubic equations using our factoring skills. It's a 3-step process. Step 1, create standard form if it's not already in standard form. Step 2, factor the polynomial. Step 3, set each factor equal to 0 and solve. All right, number 28, this is already in standard form. There's a 0 on the right side, and the left side has the highest exponent first, and then the linear term, and then the constant term. So we're ready for step 2. Factor that polynomial. This is a trinomial. You can factor it with 2 groups of parentheses, or you might even recognize it's a perfect square trinomial. N plus 2 times n plus 2. Notice you have identical factors. That's why I said that you may be recognized that it could be factored like this. Now step 3, set each factor equal to 0. So n plus 2 is equal to 0, or n plus 2 is equal to 0. Again, recognize they're just the same thing. So when you solve one of them, you've already figured out the answer. Right, if you solve the other one, you're just going to get n equals negative 2 again, and you've already discovered that n equals negative 2. Here is the solution to the equation. Now question 29. This is not in standard form. You have to get a 0 on the right side, and that can be done by subtracting 20 from both sides. It's going to create p squared minus 8p minus 20 equals to 0. Now step 2 is factoring. This is a trinomial, so it factors with 2 sets of parentheses. P times p and then -10 and +2. Those two numbers multiply to -20 and add up to -8. Step 3, set each factor equal to 0. And solve. P equals 10 or P equals -2. And number 30. This is a cubic equation because the highest exponent is a 3. So we run through the 3-step process, and the first step is to create standard form. We want to move this out to the beginning by adding 6x cubed. And we want to move the 5x over here as well by subtracting the 5x. Now let's write down what's created when we do that. 6x cubed minus 13x squared minus 5x is equal to 0. Now step 2, factor the polynomial. There's no number that divides into 6, 13, and 5, but there is a variable that appears in all places. The GCF is x. X times 6x squared makes the 6x cubed. X times -13x makes the -13x squared. And x times -5 makes the -5x. Now factor the trinomial using two sets of parentheses. One way of making 6x squared is 3x times 2x. Another possibility is 6x times 1x, and we'll try that if we can't make it work with these two numbers. Now to make -5, we could use a -5 and a +1. If I put the +1 here and put the -5 here, then it creates the -13x that's in the middle. Step 3, set each factor equal to 0. X equals 0, or 3x plus 1 equals 0, or 2x minus 5 equals 0. And solve all three equations. The first equation's already done. There's nothing to do. It already just says x equals 0. The next equation is 3x equals -1, so x is equal to -1/3. And the third equation is 2x equals 5, so x is equal to 5/2. This concludes the answers for the study guide.